All right, today we're going to continue doing our work with multiplying binomials. And today we're going to look at two special products of polynomials that have a pattern that develops. And hopefully you're going to see what that pattern is by the end of the lesson. So you have your notes, follow along, and I'll give you some time to work. Feel free to pause at any time or rewind if you need to. So, the first one is known as binomial square, because we're taking a binomial which has two terms and we are squaring it. Okay? So, what happens when you square something? Well, you take whatever is inside the parentheses and you multiply it 2 times. So you have x plus 4 times x plus 4. Now, you know what to do. Just take the first term and distribute it. X times x is x squared. Distribute the x again, plus 4x. Now go to the second term. Positive 4 times x is plus 4x. Take the 4 and distribute it to the final term, plus 16. Once you get that, you see, hopefully, that we have like terms. X squared is the only term of its kind. We have plus 4x and another plus 4x, you get plus 8x. And 16 is the only constant term. So we're left with x squared plus 8x plus 16. Okay? Compare that to what we started with the binomial square before we expanded it. Do you see anything? Do you see any pattern? Okay? Maybe you do. So I'm going to let you do the next couple examples. I'm going to write them out. So x plus 5 squared becomes x plus 5 times x plus 5. Okay, and then you would factor that or multiply that out and see what you get. And maybe you think you know the pattern already. Maybe you test the pattern and compare with what you get when you multiply it. Second one, 2x minus 7 squared means we have 2x minus 7 times 2x minus 7. The final one, 5x plus s squared, means 5x plus s times 5x plus s. Why don't you pause the video and try those out on your own and see if you can multiply those out and get the same value. All right. There's the work that I have done to get those final solutions. You can check to see with what you did to see if you figured out the pattern. So when we took x plus 5 squared, notice it ended up being x squared. We had 5x twice plus 10x and then 25. Okay. Next one we had 2x minus 7 squared. 2x got squared to get 4x squared. We had negative 7, which squared is positive 49. Notice we have these minus 14x's twice. How do you get minus 14x? Well, 2x times 7 minus 14x. And since we did that twice in the problem, we doubled it to get minus 28x in there. And then it doesn't matter whether there are variables in there. 5x got squared, we got 25x squared. We did 5x times s twice, so we doubled that and we got 10xs. Then the s got multiplied by the s to get s squared. Okay? Feeling confident? Good. Let's move on. Okay? These are known as sum and difference. Okay? These are two binomials that look very similar. One is a sum, the other is a difference. And we'll find that another pattern results. So if we multiply, distribute these binomials again, x times x is x squared. X times minus 4 is minus 4x. Plus 4 times x is plus 4x. And plus 4 times negative 4 is negative 16. like terms, notice they're opposite, so they cancel out, so we're left with x squared minus 16. Maybe you see the pattern already, maybe not. Try these next 3 examples. Pause the video, and we'll go through. All right, we're back. So, check what you did. Compare it with what I've done here. I've distributed all the binomials out, and as you can see, these terms in the middle always cancel out. Why is that? Well, because one time we're multiplying by the positive, the other time by the negative. And they're opposites, so they cancel each other out. So you see the pattern that develops? Here's that first term gets multiplied together. Second terms get multiplied together. Okay, let's put that pattern down on paper now. Okay, the square of a binomial, for instance, 3x plus 2, and we square that. Okay, what happened when we multiplied that by itself twice? So we multiplied the first term together, squared that first term. Then we took the first term times the second term in the other binomial, which is the same as the second term in the first term in the other one. So we multiply that, 2 times 3x is 6x, and we did that twice. So we double it. And then we square the final terms, plus 4. Okay? So we can generalize that in algebraic terms, x plus a plus b squared. So any binomial, you have the first term, we call a in general terms, second term b. So what happens? Well, we took that first term and we squared it. We multiplied the 2 terms and we doubled it. 2 times a times b. And then we took the last term and we squared that one. Okay? Sum and difference pattern. So for instance, 3x plus 2 times 3x minus 2. So in that case, we squared those first terms, and then once we multiplied that term, we realized it was the opposite of this one. So those canceled out, multiplied the final terms. So generalize a plus b times a minus b. So the first terms get multiplied together. We do a times negative b, b times a, those cancel out, so we do b times negative b minus b squared. So a squared minus b squared. The first term squared minus the second term squared. Okay, so we can apply that in all situations. Now, an application of this would be a way to multiply using mental math. You might think, well, why would I multiply 37 times 43 in my head? I already know how to do that. 37 times 43. And then you go through your standard algorithm. 7 times 3, 21, carry the 2. 3 times 3 is 9, plus 2 is 11. 4 times 7, 28. 4 times 3 is 12, plus 2 is 14. Add them up. You get 1,591. Well, it's been shown that if you're able to break apart numbers in a different way and to see that numbers aren't just 37 and 43, that if you're able to see that, well, 37 is equal to 40 minus 3, and 43 is the same as 40 plus 3. You know that's true, and the way you can break that apart and work with it, makes it sometimes easier to do the math in a different way. And so 37 times 43 is the same as 40 minus 3 times 40 plus 3. You think to yourself, well, that looks similar to what we've been doing. It's 2 binomials. One's a sum, one's a difference. So what do we do in those cases? Well, we multiply the first terms, 40 times 40, 1,600. Because I know 40 times 4 is 160. Times another 10 in the 40 gives me 1,600. And I know these terms are going to cancel out. So I just do the negative 3 times the positive 3, which is negative 9. 1,600 minus 9 is Hey, look at that. 1591. See, I told you it was right. Next case, 45 squared. Well, you can do the same general algorithm again if you wanted to. Or think, well, I know 45 is 40 and 5. And I know how to square both of those numbers. So instead of doing 45 squared, I'm going to do 40 plus 5 squared. And you remember, okay, 40 plus 5 squared. So I've got 40 plus 5 twice. So that means first term, square it, and multiply it by itself. 40 times 40 is 1600. Then I know I'm going to be multiplying 40 times 5 and 5 times 40. So I take these two terms, 40 and 5, multiply them to get 200, double it. So I do that twice. Then we square the last term because 5 times 5 is 25. 1600 plus 400 is 2000, plus another 25 is 2025. Nothing else. You can impress your friends by your mathematical genius. Why don't you try those three bottom examples? Practice breaking those apart into numbers that you can work with, and then compare with what I got. All right, and we're back. So, 15 times 25. Break that into 20 minus 5 and 20 plus 5. Sum and difference pattern. So first term, 20 times 20 squared, it's 400. Subtract the final terms, 25 to get 375. Okay, 43 times 57 the same way, sum and difference pattern. 50 minus 7 to get 43, 50 plus 7 to get 57. Oops, what happened? All right, technical glitch, back on. All right, so we square the first term, 50 times 50 to get 2500. Multiply the second terms, minus 49. 2500 minus 49 is 2451. Okay, and then we finish up with 18 squared. Maybe you don't know your 18 squared off the top of your head. Well, you know 20 squared, which is 400. And if you subtract 2, 20 minus 2 is 18. So take the two terms, multiply them. 20 times negative 2 is negative 40. You're going to do that twice because you're squaring. So minus 80, which is 320. Negative 2 times negative 2 is positive 4 in order to get 324. Okay? One final application of this. You get this in biology. Okay, we can represent this. So in humans, the gene S is for straight thumbs, gene C is for curved thumbs. Any gene combination of C results in a curved thumb. Suppose each parent has the same gene combination. To make a Punnett square. Okay, maybe you haven't learned this yet. You will. Okay, so in biology, maybe you got some of this in grade school. So parent has that combination. The other parent has this combination. So one possibility is they both get the big C, or they get a big C and a little s, or a big C and a little s, or two little s's. Notice how they get those combinations.